Hey everyone, and welcome back to my channel. Today I wanted to talk to you a little bit about how I teach math. Specifically, how I will go through the process of moving my son from arithmetic and transitioning to algebra. I firmly believe that math is truly a language. It's a method used to communicate information. I also believe that math is all about questions. It's allowing for curiosity. It's allowing the child to ask the question, why? And then also using various steps and processes to help answer the question, why? So today I'm going to go through a few basic elementary techniques and methods that I'm going to bring into my homeschool to kind of reteach my son how to properly and logically and conceptually think about math. And my daughter, who's currently 2 years old, once she is in like pre-K 3, pre-K 4, or kindergarten, I'm also going to start teaching her math this way. I also want to let you know that math hasn't really changed, guys. Addition is addition, subtraction is subtraction, multiplication is multiplication. The order of operations is the same. Algebraic expressions are the same. The only thing that may have changed within the scope of math is the approach or the steps that one may take to solve the problem. And I'm saying that because if you are worried about what edition of book you should purchase, should I get the first edition or should I get the second edition? In my opinion, it doesn't matter, especially in math and science, because those concepts are the same. They're not going to change. But again, the method or approach may change depending on your state as well, especially if your state is Common Core. So when you are teaching your children math, you may want to consider giving them the answer and then having them talk through the process of finding the solution for that answer. So if I'm giving my child this problem, I may say 31 plus 33 equals 64. I want you to explain to me, how did I get 64? 1, is 64 the correct answer? 2, what steps or approach are you going to use to get this answer, assuming it's correct? And allow the child to narrate and explain their thought process in finding the answer. That helps with problem solving and critical thinking skills, along with how to analyze and process information properly in a logical manner. So I'm going to just show you again a few examples of how I teach math within our homeschool, just to again get my child prepared to move from arithmetic to algebra. I ask that you be open-minded when watching the video, and that you ask any questions that you may have in the comment section below, and I'll get back to you at my earliest convenience. Okay, guys? But again, this is how I teach math, which is going to be very different from what you may have learned in school, and from what the textbooks currently show, and from what public schools are currently teaching. Okay, so here we go. So this is something you can, teach a 3, 4, 5, and 6-year-old, okay? When you're teaching them about math, again, you're explaining to them that math is a language. So when we talk about numbers and we talk about equations, we also want to remember that we shouldn't just say 1 plus 1 or 2 plus 1. 1 plus 1 is 2, 2 plus 1 is 3. Yes, that's correct. 1 plus 1 is 2 and 2 plus 1 is 3. However, because math is a language, you want to help the child understand that something should come after the number. What are we talking about? We're talking about 1 what plus 1 what equals 2 what. What comes after the number? What are we talking about? What is the object that we're talking about here? So when I teach math, I like to say one, in this example, pencil plus one pencil equals two pencils. Again, I don't just teach 1 plus 1 is 2, 2 plus 3 is 1. Because technically, if math is a language, this says 1 nothing plus 1 nothing equals 2 nothing. 2 nothing plus 1 nothing equals 3 nothing. That's what you're really saying. But it's really confusing to teach the child that concept, but it's much easier to teach it to them in this way. Math is a language, and when we're talking about math, we're talking about putting things together or taking things apart, putting things together or breaking things apart. So that's what math is about, okay? It's a language. That's the first thing. Second thing I would say is if you're teaching the child the concept that two like items are the same, can be added together. Remember, we said one pencil plus one pencil equals two pencils. So if we're teaching them that we can add like items together, you know, when you get your problem, your answer, all you're doing is bringing down that like item, the pencils, right? So that's the concept we're teaching them. We can add or subtract like items. Now, if they understand that concept, we can say, can I add one pencil to one orange? I'll give you a moment. Can you add one pencil to one orange mathematically? If we're looking at something physically, and I literally have a pencil, and I literally have an orange, and I'm putting those items together, all I'm doing is bringing those items together. But I'm not really adding them because they're not in like terms, okay? They're not like items. So this would have, there would be no answer. This would have no answer actually in mathematics, in elementary mathematics, okay? So let's keep going. Another thing is when we teach our children math, we kind of say, hey, what's 1 and 1 or what's 2 and 3? Look at what you're saying. You're saying what's 1 and 3? What's 1 and 1? Can you solve that? Can you help me understand what 1 and 3 is and what 1 and 1 is? Is the answer 4? Is the answer 2? No, it's not. It's important to teach your children about mathematical functions. What does the addition sign mean? The subtraction, multiplication, division, and the equal sign. What do they mean and why is it important to include them in our equation? They tell us what to do. They tell us the function that we should perform to get the answer. Because every single one, if used in the same example, can give us a different number or a different answer. So, what is 1 and 3? That just means we're bringing our 1 and our 3 together. And that's 13. What does 1 and 1 mean? That just means we're bringing our 1 and our 1 together, and that's 11. So I'm showing you this example just to explain to you how important it is to ensure we're using the correct terminology and our children understand the correct terminology when doing a math problem. Earlier in this video, we talked about that one pencil plus that one pencil. This is why it's important. Remember, we taught our kid that we can add like items together. And by us adding like items together, all we're doing is doing the function, in this case addition, for these two numbers to get 2, and we're bringing that like item down. You can give them another example. If you know the pattern and you understand this, then what is 3 dogs plus 2 dogs? If they understand the pattern, the logic behind the patterns that we're teaching them. Then you would say 3 plus 2 is what? And they'll count on their fingers, they'll use their manipulatives, and they'll say 5. And then they'll say 5 dogs. And you'll say, well, how did you know the answer was 5 dogs? You're going to talk to them and allow them to narrate and explain their process. And they'll explain 3 plus 5 by showing you the manipulatives. They're putting 3 blocks and 2 blocks together, and that gives you 5. And then since we're talking about dogs, then obviously we have to keep it in the same problem. So if we're talking about dogs, I'm just bringing dogs along for the ride. 5 dogs. If they understand that concept, then go a little further. What is 2 million plus 1 million? And you may be saying, really? A 3-year-old, 4-year-old, 5-year-old, 6-year-old, we're teaching them how to add millions. But remember, it's teaching them how to add when using like terms, okay? So they already know this is the addition sign. They know what the addition sign means, right? They know what 2 and 1 looks like. So they're using their fingers, they're using their manipulatives or their blocks to put the each individual part together, and they're saying 2 blocks plus 1 block equals 3 blocks. And since we're talking about million, then we're talking about 3 millions. So 2 million plus 1 million is 3 million. Again, we're teaching them the pattern and the logic behind what we're doing. So if they understand that, then you'll say, okay, I'm going to trick you now. What is 1/4 plus 1/4? And they'll do their math in their head or use their manipulatives, and they'll say 2/4. And you'll say, what? How did you figure out that 1/4 plus 1/4 is 2/4? Well, this is why. In their heads, this is what they're seeing. They're seeing 1/4 plus 1/4 equals 2/4, right? So this is what they're seeing in their mind. They use their fingers or their manipulatives to tell you 1 plus 1 is 2. And since we're talking about fourths, that's why they knew it was 2/4. Okay? Hopefully you're getting the concept and you're getting the pattern as well. Here's another example. If they understand that pattern and we say 2x squared plus 5x squared equals what? They don't care about what this looks like and what it means. They're not concerned about that, nor are you. The point is, these are like terms. And because they're like terms, they understand they're going to bring that down in what they say. They're not writing it out this way, guys. Okay? Nor are you going to write it out this way. I'm just teaching it to you so that you know how to explain it to them. So they know they're going to bring that like term x squared. There's a word called x squared. That's all they know. They're going to use their fingers, use their manipulatives to add 5 to 2, and they're going to say 7x squared. This is how it's written, but in their mind, you know, they just see 7x squared. That's all they see. And again, you're teaching them that they can add and subtract like terms. Okay? Another example, let's talk about multiplication. Let's say you are telling your child to learn their multiplication facts, and you need them to understand that information so they can recall it quickly when they're going through a problem or when they're getting ready to solve a problem. It just makes life easier if they understand their facts, right? So help them understand why it's important to learn their facts. Help them to understand what this means. So what does 7 times 5 mean? 7 times 5 is written as 7 times 5. It can also be written as 7 5 times. 7 5 times. So let's talk about it. 7 times 5. 7 times 5. And in my homeschool, when I'm talking about math, we also talk about different ways of showing something. So as a side note, I would add another lesson. I would say, do you know that there's other ways to write multiplication problems? And I would do this for a fourth or a fifth grader. I would say we can write 7 times 5 in so many different ways. Let me show you. We can write 7 times 5. The x means to multiply. Did you know that we could also write 7.5? That dot means to multiply. Did you know we can write 7 parentheses 5? And the parentheses means to multiply it with whatever's outside the parentheses? Did you know that? So that gives the student additional information in how to look at math or multiplication in different ways. So that's just a side note you would kind of teach them. But let's get back to this example. So we know 7 times 5 is written like this, and we also know 7 times 5 can be written as 7 5 times. So let's write 7 5 times. 1, 2, 3, 4, 5. Right? We wrote 7 5 times, and all you're doing is you're going to add them together. So this shows them that 7 times 5 is repeated addition. So which one would you rather do if you're trying to solve a problem? Would you rather do repeated addition for all your steps within one problem? Or would you rather learn your math facts? They're going to say, I'm going to go ahead and attempt to learn my math facts because this is like way too long. So intuitively, you have taught them that it's more efficient and it's quicker to learn the math facts than to do repeated addition. But you have also taught them that there's a link between multiplication and addition. And you can do the same thing with subtraction and division. Show them the link between those two things and help them understand why it's important for them to learn their division facts. And when I teach math, if we're adding this together, I like to, write the steps out. So I'm not sure if you can see all the way down there on my board, so I'll write it up here. So if we're doing 7, we're multiplying 7, 5 times, or adding 7 5 times, 1, 2, 3, 4, 5. When I do my math with them, I like to do it in steps. 7 plus 7 is 14. I'm going to bring down my sign, bring down my next number. That's going to give me a number. That's going to give me 21. I'm going to bring down my sign, bring down my number. 21 plus 7 is 28. I'm going to bring down my sign, bring down my number. Okay? 28 plus 7 is 35. So that is just showing them a way to add numbers as well. I like to teach everything in steps and in process because, again, when you are transitioning your child from basic arithmetic, elementary, to like 6th grade arithmetic, you want to transition them or prepare them to efficiently transition to algebra. And algebra is all about patterns, it's all about solving for x, it's all about finding links, and it's all about writing out your steps, writing out the process, being able to explain it and narrate it. And then if your answer is wrong, it's all about going back to your individual steps and understanding where you went wrong in effort to correct the problem. Hopefully this makes sense, guys. Hopefully you're finding this information to be valuable thus far. So let's talk about place value. Place value is the power of position. I'm going to just put PV for place value. Think of place value as being the power of position. And I want to actually write that out. Power of position. And if I am misspelling anything, guys, please forgive me. This is not a spelling lesson. I just kind of wanted to share with you a little bit about how I am doing our math. And if you are seeing a glare, I really hope you're not, but if you are, I really do apologize about that. So place value. Let's give them a problem. So when I'm teaching math, I like to ensure that we are using the correct terminology. So of course you're going to make sure they understand what is a dividend, what is a quotient, what is a divisor, and things of that nature. So just for your edification, the number outside of your problem is going to be your divisor. Your number is going to, within your sign, is going to be your dividend, and the answer to the problem, which is above this line, is going to be your quotient. Okay, so the number 148. Ask yourself, what does that number actually mean? Well, in order to understand what that number actually means, you have to understand the place value. You have to understand where is the position of power. Well, we know that the decimal is actually after the number. That's our place value. That's our power of position, right? So if that's the case, why do we move the power of position 1 or 2 spaces to the left when we're trying to solve the problem? In school, they teach us the following. 4 can't go into 1, right? It can't go into 1, so we're going to go to the next number. 4 goes into 14 3 times. So we put the 3 above the tens place. 3 times 4 is 12. 14 minus 12 is 2. And then we keep going, right? But is that actually correct? No, that is not actually correct. We should not move the position of power. So if we can't move the position of power, what can we do to make the problem a little easier for our children when trying to explain how to solve the problem? Well, we're going to teach our kids that we can write this number out exactly in the way it is written, right? However, we're going to use a different approach. If you understand place value, you can tell me what place value the 1 is in, what place value the 4 is in, and what place value the 8 is in. What place value, guys, is the 1? It's in the 100s place, right? So 1 times 100 is 100. What place value is the 4 in? The 4 is in the tens place. So 4 times 10 is 40. What place value is the 8 in? The ones place. So 8 times 1 is 8. And all we're doing is we're adding it together. 140 and 8. Another way for understanding addition is the word and. Depending on your problem, the word and can mean to add. Okay? So now that we know this, let's go ahead and redo the problem. Four goes into 100. How many times, guys? 4 goes into 100 25 times. 4 goes into 40. How many times? 10. 4 goes into 8. How many times? 2. And again, we're just bringing our signs up, right? So, what is the answer? 25 plus 10 plus 2 is what? 25 plus 10 is 35. 35 plus 2 is 37. Our answer is 37. You would have definitely gotten the same answer if you would have went through the longer process. But again, it's all about teaching math without changing what the numbers mean. By us moving our decimal point to between the 4 and the 8 in order for us to divide changes the meaning of that word, number. And in math, we're not changing the meaning of the numbers or the logic behind the numbers. We want to maintain the integrity of the numbers throughout the entire process. And making sure the child understands this makes it easier, again, for them to transition from arithmetic to algebra. Something else. What happens if we were doing this and we had a remainder? I'm just doing this as an example, okay? This is fictitious, but I'm just doing this as an example. So if this problem here wasn't even like it is now and it had a remainder, then all you would do is you would add your remainder. So let's say this was a 9, okay? If that was a 9, then you would say How many times can 4 go into 9? Oh, 4 goes into 9 2 times, but we're going to have a remainder 1 with that. So now what is your answer? Your answer is now 25 plus 10 is 35. 35 plus 2 is 37, but we have a remainder 1 here. So our answer in this case will be 37, remainder 1. And if you had a remainder in the tens place, or if you had a remainder in the hundreds place, all you would do is you would add your whole numbers together, and then at the end you would add all the different remainders together, and you would still get the same answer. Okay? Hopefully you're getting this, guys, and this is not too confusing for you. So now let's go and let's talk about the number line. I recommend that you incorporate negative counting in preschool. When your child is in the third, well, not third grade, but 3 years old or 4 or 5, go ahead and incorporate negative numbers. Why not? So what is a number line? A number line just represents all of our numbers going from left to right, right? So I'll write it out for you. So when we teach our kids to count, we normally say 1, 2, 3, 4, and go up. However, is that the right way to teach our kids to count? I would beg to differ, and I would say no. When you're teaching your kids to count, always start from 0. Why? Because 0 is a number. Would you agree? What does 0 actually mean? 0 means nothing. So when you're teaching your kids how to count, you're going to say, we're going to start from the number 0, and then we're going to move to the right. 0, 1, 2, 3, and there's a few things going on here. 0 is an actual number that means something, and 0 means the word nothing. And as we're moving to what side? We're going to the right. So as we are going to the right, the numbers are getting bigger, right? The numbers are getting bigger. Now, since we know 0 is a number and 0 equals nothing, if we move to the left side of 0, is there anything there? Is there a number that comes before 0? You'll be surprised that some 5 and 6-year-olds, since they know that 0 equals nothing, they'll say 1 nothing, 2 nothing, 3 nothing, and they'll keep going. Because if they know 1 comes after the 0, then intuitively they may know that 1 also comes before it, but it must be a nothing in front of it. Nothing 1, nothing 2, nothing 3. And that is quite okay, and they are 100% correct in that thought process, and you're teaching them links and patterns in that way. Okay? So, and then you would just say when the numbers are going to the left of a number line, the numbers are getting smaller and smaller and smaller and smaller, and they're actually smaller than the number 0. They're smaller than nothing. Okay? And you can demonstrate this by getting a big piece of butcher paper, and you can do a nice number line, have them help you create the number line, and have them walk the spaces. Okay, you can have them start with 2 or 3, and you're going to tell them, let's walk back 3 spaces if they're on the number 2. They're going to hit the 1, they're going to say 1. They're going to hit 0, and then they're going to hit -1, 1 nothing. And you'll just play little games like that. And again, that's just teaching them the concepts of numbers, and that every number, may it be to the right or to the left of 0, actually has a meaning. They don't have to understand what that meaning is. They don't have to understand the different signs. But if you teach them the basics of this type of information, it'll help them put links and patterns together, and it'll help their minds be ready when they're ready to transition from arithmetic to algebra. And then of course you can teach them what the different signs mean in like the third or the not third, but in like the 4th or 5th grade or earlier if you so choose. Next example. Normally when we teach your kids math like this, we teach them that we're going to do something called regrouping. But let me ask you a question. What does the word regrouping mean? Logically. Common sense. Think about the word regroup. Think of what the word regroup means. What does that mean? Can you even use that word based on your definition with numbers? The answer is no, guys. We cannot regroup numbers. We can regroup people. We can regroup objects. But you can't honestly regroup numbers. So why do we learn it this way? Why does school teach us that concept? In my opinion, really, I don't know why, but in my opinion, I'm thinking they're teaching us how to bring this concept into math just to make it more, allow the process to go a bit quicker when kids are trying to complete a problem in order to complete a test or complete a quiz. But again, in my opinion, there's no such thing as regrouping in math. You can't regroup numbers. So how do we teach our children how to properly add numbers if they're not regrouping or using that concept? Well, first, place value. It's all about place value. What place value is this 3 in? The 3 is in the tens place. So what does that mean? If the 3 is in the tens place, that just means 3 times 10, and that's 30. What place value is the 7 in? The 7 is in the ones place, and that just means 7 times 1, which is 7. Let's keep going. I'm doing this quickly, but if you were doing this with your kid, you would absolutely take a slower pace, okay, in teaching them this information and doing it repetitively. So now let's add. 30 plus 20 plus 10 is 60. Okay, they can use math facts, counting by tens, whatever they want to get the answer, but 30 plus 20 is 50, 50 plus 10 is 60. Now let's move to this ones place value. When I'm teaching my kids to do math, I also teach them how to base counting, counting by 10. And all that means, guys, is when you are adding numbers, you want to find numbers that are equal to 10, add those numbers first, and then add everything else afterwards. So that's also an important concept that you may want to bring in to your homeschool and teaching your children how to add. So let's show you an example of what base counting is. Where can I make a 10 here? I can make a 10 by adding 5 and 5. So 5 and 5 is 10. It's easier to say 10 plus 7 rather than 7 plus 5 is this number, then whatever that number is, then we add 5 to it. So again, you try to find all the numbers that are equal to 10, and then you add from there. So 7 plus 10 equals what? 7 plus 10 equals 17, right? 17. What place value is that 1 in? That 1 is in the tens place. So 1 times 10 is 10. What place value is that 7 in? That 7 is in the ones place. 7 times 1 is 7. Also, when you're base counting by 10, if you're doing that, then you can just add all your tens together, and you would put it in your tens place and add all your ones together and do that, okay? So now, what is our answer? 60 plus 10 is 70. Bring down the addition sign. Bring down the 7. 70 plus 7 is 77. So our answer here is 77, and we did not have to use that regrouping concept. Hopefully this makes sense. Yes, the process is longer, guys. I totally get it. I totally understand that, but we don't want to lose the integrity of our numbers, okay? I'm going to go ahead and give you a bigger example. So let me go ahead and write it on the board, and then I'll come back. So here's another example. Based on what we just talked about, let's do this example. 356. What does 356 mean? Remember, we're talking about place values here. So 300 plus 50 plus 6. 254 is 200 plus 50 plus 4. 173, 100 plus 70 plus 3. Do you guys see what we're doing? Do you know what this is called? This is called expanded form. So when you teach your kids math, you'll help them understand the concept behind the numbers by using expanded form. Okay, so that's what this is called here. So let's go ahead and do our adding. You want to also keep all your numbers lined up in math. Our hundreds are in the hundreds place, it's in a nice little column. The tens are in the tens place, nice little column. And the ones are in the ones place, nice little column there. Okay, so you always want to keep everything lined up and neat when you're doing your math. 300 plus 200 plus 100 is 600. Watch what happens here. 50 plus 50 is 100. 100 plus 70 is 170, right? But the 170 in expanded form is written as what? 100 plus 70. Now let's go to our ones place. 6 plus 4 is 10. 10 plus 3 is 13, right? So how do we write 13? 1 is in the tens place and 3 is in the ones place. So now let's add all our information together. 600 plus 100 is 700. 70 plus 10 is 80. And then we have 3. So what do we have left? 783. Let's go ahead and do one more problem. I want to show you that this process of thinking can also work with subtraction. And remember, we taught our kids the proper way of thinking about numbers using that number line. So this is where it comes in handy. 23 minus 18. When we did math in school, we would borrow from the 2, right? Cross this out, make it 13, borrow from the 2, make that a 1, and solve from there. However, that's not really the appropriate way. You can't borrow numbers. You can borrow money, but you can't borrow numbers. So here's the right way to think about it. 2 is in what place? The tens place, which is 2 times 10. The 1 is in what place value? The tens place. What's 1 times 10? That's 10. Now let's look at this one here. The 3 is in the ones place. That's 3 times 1. And the 8 is in the ones place. That's 1 times 8. 20 minus 10 is 10, right? And we are bringing down our minus sign. So we have 3 minus 8 is 5, right? So now 10 minus 5 is 5. That's the proper way of doing subtraction, the proper way of doing math. If we are, well, one more example. I want to give you an algebra example, a simple algebra example. When teaching your kids algebra, you can say 2 times 10 plus 3. Remember we learned that there's different ways of showing you multiplication? Well, this is one of those ways with the parentheses. So this problem simply means 2 times 10, right? We're going to do that first, and then we're going to add 3. Also, do you remember the conversation we had about order of operations? And you can bring all those concepts back in. So what does that mean? What's 2 times 10? 20. What's 20 plus 3? Or the answer is 23. Easy, right? So now what we're going to say, what I'm going to do now, I am going to take 10 out of the game, and I'm going to bring n into the game. So I have 2n plus 3. So this can mean the same thing, right? So if I said that n equals 10, what am I doing? All I'm doing is substituting the n for the number 10. So let's bring 10 back in and take n out. 2, we're going to substitute n for 10, and we're going to add 3. 2 times 10 is 20. When we add 3, the answer is 23. Again, you're teaching kids how to mathematically and logically think about math. And that's the last problem I wanted to show to you today. Hopefully this video makes sense, guys, and you understand what I was trying to say. But some additional tips that I want to give you is when you are teaching your kids math, try not to give them the answer. Okay? Help them in the process of thinking the process through. Give them the problem. Give them, I'm sorry, I said that wrong. Don't be your child's answer key. So when they solve the problem, they're asking you, is my problem right? Did I get it right? No, you don't want to be the answer key. You're going to tell them, I don't know if your problem is right, but can you help me understand why you think the problem is right? Or can you prove to me how you got that answer? Narrate, explain, show me an example, show me the steps and process you take. And in your ability to do that, I then can understand how you got your answer, and then I can help you determine if that answer was right. So don't be your child's answer key. Don't be their answer key. The next thing I would say again is to allow your children to narrate the steps to you. Allow them to talk through the steps. Allow them to explain their thought process. And always, always, always have them prove the answer. Prove why is your answer correct. And you may also want to have them draw or use manipulatives to help them through that process. Can this help with other subjects? Yes. I think a lot of what I talked about today can not only go with math, but it also can go with science. You know, help your children draw it out, talk through the different scientific concepts, talk about it, explain it, prove their hypothesis or prove their solutions, right? So guys, I hope this video was helpful. I hope you found at least one thing useful from this video. If you have any questions, leave them for me in the comment section below, and I'll try my best to get back to you. And as always, guys, you make it a great day and be blessed. Thanks for watching. Bye-bye.